multiballers. Now we all know that electrical parts can be expensive, but solenoids in particular are parts that you can probably find a lot cheaper if you know where to look. Today I'll be showing you how I was able to source my coils for pennies on the dollar. Not only is this good on the wallet, but it's also good for the environment because
you're getting the table, brother! Environmentalism isn't for the weak! You wanna be environmental, you gotta be extreme like me! I am the color Earth Sprout. I ride a bicycle made out of recycled cans to work. I sew my own underwear from cat fur. I sleep on a bed of moss and dandelions. Let's go green!
I don't know how my code works.
Look at all these wasters online. They don't know what they've got. Solenoid coils age surprisingly well. When hit with electricity, they create a magnetic field that pushes a plunger, and that lets us do all sorts of cool stuff. Let's buy these cheap parts and get to work. You got my old pinball table there?
Yeah, it's right here.
Oh, this looks good. I'm digging this. Oh, there's some kickers here, a couple slingshots, some flippers.
Yeah, it's just been sitting in my garage for years now. It never got wet or anything.
Oh.
So the electrical parts, it should be okay.
Oh, we're gonna make them okay, brother. I'm gonna get hopped up on granola bars this weekend and get them fixed up like they were fresh from the ground that grew them.
Oh, yeah?
Oh, yeah!
Oh, yeah!
Oh, yeah!
Oh, yeah!
As you can see, we have multiple different solenoids here. Some are new, some are old, some are big, some are small. But we can operate all of them with the same 48-volt power supply. Let's get them cleaned up first though. Unscrew your component so that the plunger slides out. Now we can see the extent of the damage that we're going to have to repair. You'll probably notice that the paper wrapper around the coil is in rough shape. That's okay. It can be taken off and left off entirely. This is there to prevent stray windings from shorting your circuit. If you keep a tidy circuit, it shouldn't be an issue. But if you are concerned about it, you can simply tape it up. The wrapper also includes important information about the solenoid, which we can use when calculating current requirements. This coil from Data East has 23 gauge wire and 840 turns. The wire gauge affects how much current the solenoid can handle, while the number of turns affects the strength of the magnetic field produced. Now, more turns does not inherently mean more power. In fact, more turns increases total resistance, which decreases current based off of this formula, which— oh!
We don't care about all that math. This ain't caveman times, we have computers. Let's talk about rust. That's gonna be your biggest issue when you're dealing with your old solenoids. It clogs up the shaft and prevents that nice smooth motion that we're looking for. But don't stress, brother. It can be cleaned off with the rough side of a sponge. For even older pieces, you can use a wire brush. This wire brush attachment for the Dremel works really well. You can use a cleaning agent or degreaser like Mean Green if you really need to. Mean Green was my wrestling name, by the way. Just make sure you're not using something that will leave a film. That means no lubes, no oils, no WD-45. You know I can't stand that synthetic stuff. All that stuff may work short term, but it'll dry out and gunk up your doodads. Your plunger needs to be able to go in and out totally dry, just the way I like it. Now, even though I source all my electricity from my pedal-powered generator, you can use a 48-volt power supply yourself. Most modern pinball tables use 48-volt power supplies, but some of the older ones went all the way up to 70. If you sourced your solenoids from a machine that uses a different power supply than what you've got now, that's okay. But before we go any further, what the heck is that?
That is a flyback diode, and it's very important. When the solenoid stops being powered, the magnetic field collapses, creating a voltage spike that could damage your controller. The flyback diode provides a path for the current to go back into the solenoid itself. If your solenoid is missing this, you need to solder one on. Just put it parallel to the coil itself. Now, these solenoids don't care about polarity. you can put current into either side and it will work. But now with the flyback diode on it, it does care about polarity. You should always have the white band pointing towards where the positive side of your circuit is, where the power is coming from. Now the reason we're not too concerned about matching the voltage specs exactly is because we'll be using pulse width modulation, which pulses 100% power at set intervals so that we can finely tune what the average power output is. We can do that with a transistor rated for the maximum voltage and current that we can expect from our circuit. In our case, a 48 volt 5 amp field effect transistor will work fine. The signal will be provided by a separate microcontroller loaded with our code. As we're wiring things together, make sure that you're using at least 16 gauge wire. Anything thinner than that and we'll start to see reduced coil strength. And now it's time to dial in our initial power. The way we do that via programming is to start the pulses very short. 10 milliseconds is all you need when you're starting out. Does that brief pulse press the load the length of your shaft? Then keep it there. If not, go a little longer. 20 milliseconds, 50 milliseconds, 100, even 150 if you're really pushing it. We're still not using pulse width modulation here though. What we're doing is giving the solenoid the full 48 volts over a very brief amount of time. The reason it is safe is because we're keeping that time very short. Again, we're talking about fractions of a second. If you were to hit this tiny solenoid with 48 volts for just a few seconds, it will burn out. So keep your finger on the kill switch when you're starting out. You'll be able to tell if it's overheating by simple feel. Not when it's running. If you feel any heat at all, stop what you're doing and reconsider your program. You're likely giving it too much voltage. This is where pulse width modulation comes in. This solenoid is only rated for 12 volts, but I can simulate 12 volts with a 48 volt power supply by running it at 25% duty cycle. Programming a solenoid for continuous use is a little bit trickier. Many fast action solenoids, like what you usually find on pinball tables, are not made to be held on continuously. But it can be done, and you can reduce burnout by using pulse width modulation to reduce the hold power as opposed to the initial pulse power. Start at a high voltage for about 50 milliseconds or so, and then reduce the hold power to something much lower using pulse width modulation. These continuous use solenoids are quite a bit bulkier than their intermittent use counterparts, meaning they have better heat dissipation. You can assume that most of the solenoids on your old pinball table are twitchy fast action solenoids. Actually, aren't you forgetting about dual wound coils?
Well, you can't flinch.
Well, of course I'm gonna flinch. You're throwing a table at— Ow! Dual wound coils are two coils wrapped around a single sleeve. One for twitchy fast action and another for longer hold power. These are the type I'm using on my flippers. The intermittent use ones are suitable for my slingshots and jet bumpers. And now we got flippers on this thing. And it didn't even cost us— Ugh. Thanks for watching, everybody. I'm Pinballer Shot Caller. And if you're new here, welcome. This is a series where I document my progress towards building a full-size operating pinball table from the ground up. I put out videos every single week, so now is a great time for you to subscribe. And as always, happy ball!
Happy ballin'!